Today, we're diving into a truly life-saving piece of technology, the artificial kidney. We're going to break down exactly how a dialysis machine pulls off one of the most critical jobs in the human body, from the second blood leaves the patient to the moment it comes back totally clean. Let's get into it.
Just think about that for a second. Your kidneys are this tireless, super efficient filtration system. But what happens when they fail? Harmful stuff and extra water start building up, and that creates a really life-threatening situation. So what do you do when your body's most important purifiers just go offline?
Well, you turn to this. The dialysis machine is the answer. It's a remarkable piece of engineering that steps right in to do the vital, life-sustaining job that the kidneys just can't handle anymore. It's not just a treatment. For millions of people, it's a lifeline.
You know, that term, artificial kidney, isn't just some catchy phrase. It's honestly the perfect way to describe what this machine does. So, let's get into what it is exactly.
At its core, this machine takes over the key functions of a kidney. It cleans the blood, it balances electrolytes, and it removes all that excess fluid. It's basically designed to copy a natural biological process, using some really clever chemistry and fluid dynamics. But how does it actually do it?
To really understand how this works, we're going to follow the journey of the blood itself, from the patient, through the whole machine, and then right back again. Let's trace the path.
Okay, so it all kicks off when blood is drawn into a circuit that's outside the body. A special pump keeps the blood moving at just the right speed as it heads into the heart of the whole system, the dialyzer. This is where the magic happens. Inside, all the toxins and extra water get filtered out. And all along the way, you've got sensors checking for things like pressure changes or air bubbles to make sure everything's completely safe. Finally, that newly cleaned blood is returned to the body, and this whole cycle just repeats over and over for about 4 or 5 hours. So let's take a closer look inside that dialyzer. It's not just one big filter. It's actually a bundle of thousands of these tiny, hollow, microscopic tubes. The blood flows through the inside of these little tubes, and that's where the real purification happens. So let's zoom in even more. We've seen the path the blood takes, but how does the machine actually separate the good stuff from the bad stuff? Well, it all comes down to two key scientific principles happening across a very, very special kind of wall. So the walls of those tiny tubes we just saw are made of something called a semi-permeable membrane. Think of it like a very, very precise screen door. It has these tiny pores that are just the right size to let small waste products, like urea, pass right through. But they're way too small for the essential stuff, like your red blood cells and proteins, to escape. This selective filtering is the whole secret.
And this illustrates the first principle perfectly: diffusion. Imagine your blood is like that colored fluid on the left, full of waste particles. On the other side of the membrane is a special clean fluid called dialysate. Now, nature loves balance, so the waste products in your blood naturally move from the crowded area, the blood, across the membrane into the clean, empty dialysate. The machine is constantly replacing that dirty dialysate with fresh solution, which means the toxins are always being pulled from the blood, very efficiently.
But it's not just about getting rid of waste. You also have to remove excess water. And for that, we use osmosis. You've definitely seen this in action if you've ever put sugar on strawberries. The sugar draws the juice right out. Well, in dialysate, the dialysate fluid contains things like sugar that do the exact same thing, pulling that extra water from the blood across the membrane. And that high-tech semi-permeable membrane, get this, its origins are surprisingly humble. One of the pioneers, a guy named Niels Alwal, built his early machine in the 1940s using 11 meters of filter tubes made from cellophane. Yeah, literally the same material used to wrap hot dogs. It's an incredible reminder of the amazing ingenuity that got this whole technology started. Now, while the core ideas are pretty much the same, there isn't just one way to do dialysis. There are two main methods, and the biggest difference between them is where all that filtering actually happens. So, on the left, we've got hemodialysis, which is everything we've been talking about. The blood is cleaned outside the body using that artificial dialyzer. But on the right is peritoneal dialysis, which is fascinating because it uses your body's own abdominal lining as a natural filter, so the cleaning happens inside the body. A dialysis fluid is circulated through the abdomen to draw out waste. And the biggest difference is this often transforms a major medical procedure into something that you can do at home, maybe even while you're sleeping. And that brings us to a major trend in dialysis treatment. The ability to manage your care at home is changing the lives of so many patients. I mean, when you really look at this number, 4 to 5 hours for just one session, usually 3 times a week, you start to get a sense of the incredible time commitment of traditional dialysis. A patient's entire week is structured around it.
And this is a huge reason we're seeing this shift. Home dialysis just offers a level of freedom and control that's almost impossible in a clinic. It gives patients way more flexibility with their schedules and, of course, the convenience of being in their own homes. This often means they can dialyze more frequently or for longer stretches, which can lead to even better health outcomes and a much, much better quality of life. You know, from cellophane tubes used for hot dogs to these compact, smart machines that can operate in a patient's own bedroom, the evolution of the artificial kidney has just been revolutionary. It really makes you wonder, as technology keeps getting smaller and smarter, what breakthroughs are just around the corner? What might the next generation of this life-saving device even look like?